My name is Rodney, and today I'll be teaching you about Ohm's Law. So just to give you a general idea about what Ohm's Law is, it's basically, it shows the relationship between potential differences, current, and resistance. So to get things started off, I want to invite my guest, and he's actually the one who discovered this rule, and it's none other than Mr. Ohm himself. Hi, Mr. Ohm.
Hello.
And welcome to our podcast.
Thank you for having me.
It's a pleasure. So, Mr. Ohm, can you give us a brief biography of yourself?
I would be delighted, Rodney. I was born on March 16th in Germany. During my high school years, I studied math, chemistry, physics, and philosophy. Never did I once think that I would be a great name in science one day. Okay, my scientific law, Ohm's Law, began after graduating. I studied at university, and I went to teach in a private school in Switzerland. Simply did study mathematics with professors in important universities. I was one day asked to teach an electricity lab. This is what really changed my life, because this is what began Ohm's Law. I was very fascinated with electricity. I started to study electricity, and with my passion and commitment, I started to realize that there was a relationship between potential difference, current, and resistance. This led to Ohm's Law.
Wow, that was really great. I'm sure you also went through some hardships in your life, and it must have been really tough.
Yeah, it was.
Well, you're a great hero, and you made a big difference in physics, in the world of physics.
Thank you.
Okay, so Mr. Ohm, thank you for that wonderful biography of yours.
You're welcome.
So do you want to get started on teaching about Ohm's Law?
Yeah, let's teach my law to these students.
Okay, so Ohm's Law is basically written, the main formula is V equals I times R. Okay? Basically, this is the formula you would use to solve equations relating to voltage, resistance, and potential differences.
Okay, now, these are just basically symbols. Now we want to know what each letter means. So, first, the V is potential difference. Sorry if my handwriting's messy. So V equals potential difference. Okay, I equals current. And R is resistance.
So here we have what each letter represents. So using this formula, we can change it up so it can represent any kind of situation. Okay, so if you want to change up the formula, so for a different situation, if you want to find out the resistance, then you just have to change up the formula so it accommodates R. in this case, to find resistance, you would divide potential difference from the current. You just simple formula. Okay, so I'm sure it can be quite confusing, but we have a trick, and this trick can help you in any situation. So here we have a table that gives you a general overview of the different kinds of equations that you would need to know for Ohm's law. So our first case is to find the value for potential difference. We have the values for current and resistance, but however we do not have the value for potential. So we have to find the value for potential difference. And potential difference, the symbol is V. So we just this is our main formula, and we would use V equals I times R. So that's how you would find potential difference using what we have, which are current and resistance. We need to find current, which is I. So that's what we need to find, but we have the value for potential difference and the value for resistance. To find the value for current, we just rearrange this formula so that it would accommodate the value for current. So instead of memorizing all these formulas, there's a simple trick that you can use, and this trick is called Ohm's triangle. So as you saw, this triangle has the different values: potential difference, the current, and the resistance. So this little triangle can be used to find the values for any of these three variables. To find the value for current, all we have to do is just for current, we just follow this simple rule. So to find the value of current, we just simply cross out the variable I, because current, we use the symbol I for current. So we cross out current, and we're left with V and R. And the line that's separating these two variables is this line right here. And this line is known as the division line. So we divide in this case. This time, we cross out V, and we're left with I and R. So the line that's separating these two variables is this line right here. And in this case, this is called the multiplying line. So in this case, we would multiply current by resistance. So this line right here represents multiplying, and this line right here represents dividing. In this case, we just plug in what we have, and we'll find out what our equation will be. So we have current, so cross out current. We do not have current, so we cross out current, because that's what we have to find. And we're left with the potential difference and the value for resistance. And the line that's separating both of them is the dividing line. So to find the value for current, all we have to do is divide V by R. So current would equal potential difference divided by resistance. And that's what we have right here. So this chart is very simple, and it doesn't require you to memorize all these different equations. This simple tool can help you a lot. So finally, we have this case. We have the values for potential difference and the value for current, but we do not have the value for resistance. So we do the same thing we did before. We substitute what we have and we cross out what we need to have, what we need. So we need resistance. So we cross out resistance and we're left with potential and current. And the line that's separating the both of them is this line right here. So once again, you divide. So to find the value of resistance, it would be resistance will equal V divided by I. And once you have the final answer, we would use this unit. And this unit is called ohms, the ohm unit. And this unit was actually made in honor of Mr. In honor of Mr. Ohm's work. So, so these are the three main equations that you have to know. And instead of memorizing all these, V equals I times R, I divided by R. It's all that you don't need to go through all that trouble. As long as you memorize this little chart and you draw it in every test and assignment or anything, you'll be great in this part of the unit, this part of the lesson. This simple trick it's called Ohm's triangle. This is called Ohm's triangle. And it can help you in a lot of cases and can save valuable marks. Now, let's talk about some rules. Every formula has a rule, and in this case, Mr. O will explain the rules.
Alright, for I describe potential difference and current are affected when one of the values change. You can see this in V equals IR. When one value changes, the other changes. But the most important thing you need to know, as long as the temperature stays the same, the formula won't change. It will always be V equals I. And basically, that is one of the most important rules. Now, the minor rules are, the resistance of a conductor remains constant. So resistance always remains constant, and a current is directly proportional to potential difference. You can see it in the diagram. Those are the main rules, and remember, when you're solving an equation, always remember these rules. Thank you.
Alright, so this symbol equals resistance. This is a very special symbol as it was made in honor of Mr. Ohm's work, and this and you use this symbol in any situation, where you have to find resistance. And I hope you learned something. We just want to give you some sample questions and to see, just to show you how to do it. And so Mr. O will help you solve this first question, and I'll help you with the second question.
A current of 4.0 flows through a 40 ohm in a circuit. What is the voltage? So to help me with this problem, I will draw the Ohm's triangle. So, what I is current. So the current in this problem is 4.0. And R is resistance. And since we know that that sign, that symbol, that looks like a horseshoe, is actually an ohm symbol, which is also known as resistance. So the resistance is 40. So now that we know the current and the resistance, it's basically we're calculating the formula. So to find the voltage, all we need to do is multiply 4.0 by 40 ohms. And we get the answer 160 volts. So the voltage is 160. The voltage is 160. The answer to this.
So here's another question that I want to help you, I want to teach and help you solve it. So, an electric stove is connected to a 240 volt outlet. If the current flowing through is 20 A, what is the resistance? It may seem hard, but usually what we learn, it can be it's very easy. So, I want to start off with Ohm's triangle. So, this trick is very useful in many cases. So, what is given? Okay, we know that the voltage or the potential difference is 240. And the current is 20. And what is resistance? So that's our question. So to solve this, using the Ohm's triangle, we can solve it very easily. So we have the voltage and we have the current. So to find resistance, we just simply divide. We simply divide voltage by current. So basically it will be resistance R will equal V divided by, so now that we have the formula, we just simply substitute the values. Resistance will equal 240 divided by 20. So, right, you just solve this. 240 divided by 20 will equal the resistance of the electric stove is 12. So this is basically how you would solve it. Show your steps and always conclude with the statement.
30 voltage battery generates a current through a 15 ohm resistor. How much does the battery generate? So basically we're solving for the current here. So to help us, we're going to draw the triangle. So the formula to solve current is I, the current, divided by over voltage divided by resistance. So here we're substituting V for 30 and R for 15. And through this formula we can find the current. So I equals 2A. So the battery generates two, which is basically the current. So yeah. So the battery has a current of 2. And voila, we have our current. So I hope this has answered your questions, and I hope you understood everything we taught in this podcast. And I hope you use the knowledge from you learned today to help you in the future.
Thank you, Mr. Ong, very much, and I hope to see you in the future. And guys, thank you for watching, and we'll see you next time.
And have a good day.